Hi, I am Jasper Garma, and in this video we'll learn how to draw Pascal triangle. And what is Pascal triangle? Well, Pascal triangle is a triangle array of numbers where each number is the sum of the two numbers directly above it, with the first and last number in each row being 1. Now, let's talk about history. Pascal triangle is named after a French mathematician Blaise Pascal, who studied its properties in the 17th century. However, the triangular arrangement of binomial coefficients, which is foundation of Pascal's triangle, was known to Chinese mathematician Ji Xiang in the 11th century, over 500 years before Pascal. The Persian mathematician Al-Karahi also wrote about the triangular array of binomial coefficients in the 10th century. The earliest known written description of the triangular in Europe is the best medieval Italian mathematician, Fibonacci, or also known as Leonardo of Pisa. In his 1202 book Liber Abaci, the triangle also appears in the work of other medieval European mathematicians such as Yang Hui and Guglielmo Libri. Pascal triangle is used in many areas of mathematician, including probability theory, combinatorics, and algebra. It also has many applications in physics, engineering, and computer science. Now, let's begin how to make Pascal triangle. Now, to begin with, to draw Pascal triangle, the first number we are going to write is a number 1, the top here. Then, directly below that, we are going to draw two other ones. This will be our starting point. This. So you need these 3 ones in this sort of triangular shape. Once we done that, we can get started. We are going to take the sum of the 2 terms. So in this case, the 2 ones, the sum of 1 plus 1 is equal to 2. So we write 2 below them and between them. And to complete this line, by writing 1 on each end. So let's put there 2. Let's end this line with the end on each end of 1. Next, we do the same thing for the next line. Looking at the third line here, we have 1 plus 2. And 1 plus 2 is equal to 3. So we write 3 in between 1 and 2. On the line below. So we already write the 3 below them. Similarly, we have 2 plus 1, which also equal to 3. So we write 3 between and below them. Once again, we complete this line with 1 and 1 on either end. There. So next is we carry on this way to write the 4th line. We can see that we have 1 and 3. So this is 1 and 3. 1 plus 3 is equal to 4. So we write 4 right here. We can carry on by adding these 2 numbers. So 3 plus 3 is equal to 6. And carry on the next numbers, or add up the next step. So 3 plus 1 is equal to 4, and we end this line by putting 1 on each end. Following this method, we can draw all the Pascal triangle, and one of the things will be seeing next how to use Pascal triangle to help us expand the binomial expansion. Things like a plus b raised to n, or the power of n, which will be discussed by Charles Ildepenso. So I'll be leaving for now. Bye bye. Thank you for watching.
The last video lesson is about Pascal's triangle and history. And for this video, I will show you how to expand binomial using Pascal's triangle. But before that, what is binomial? It is a mathematical expression of two unlike terms with coefficients and which is raised to at least the power of 1. Example, a plus b, x plus 2 squared, a plus c cubed, and y minus 4 raised to 6. To expand binomial, there are many different methods: long multiplication, FOIL method, and the method that I will be talking about, Pascal's triangle. So this is our binomial, where a is our first term and b is the last term. Then if we raise a plus b by 1, that is equivalent to a plus b. Then if we get the square of our binomial, which is equal to a squared plus 2ab plus b squared. How did I get this? Simply take a look at our Pascal's triangle. Here, as you can see, the exponent of our first binomial is 1. So we will use this row, which is also have the exponent of 1. 1a plus 1b, or we can just simply write a plus b. In our next binomial, the exponent is 2, so we will use this row. We will use the coefficient of 1, 2, and 1. The coefficient of the first term, it goes in order from left to right. It's 1, and then we are gonna have the first letter, a raised to the second power. And then the second part of the binomial, which is b, and it's going to raise 0 power. Now, these two exponents must always add to 2, or this particular number. The next term will have the second coefficient of 2. Now, this exponent will decrease and this one will increase. So, this is going to 1, the same with this. Now, the third term will have the coefficient of 1. This exponent will now be a 0, and this exponent will be raised to 2. The next is a plus b cubed. It is equal to a cubed plus 3a squared times b plus 3ab squared plus b cubed. Now, I am going to show you an example. Use Pascal's triangle to expand x plus y raised to 5. Since the n is equal to 5, we will use the fifth row in the Pascal's triangle. As you can see, the fifth row is here. This will be the pattern of the polynomial. So let's try to answer it. First, get the numbers from the fifth row. 1, 5, 10, 10, 5, and 1. We will get the polynomial faster by using these numbers. To get the first term of the polynomial, we need to copy first the coefficient which is equal to 1. Then we will multiply it to the first term, which is x times y is the second term. So since the n is equal to 5, the x right here will start with 5. And the starting exponent of y is equal to 0. The next term is 5. And this time we also have x plus y. Then the exponent of x here, we will just subtract the first one. So since the first exponent is 5, here in the second term, x is raised to 4. Then let's go to the y. Since there is an exponent that is 0 in the first term, the next term we will just add 1. So 0 plus 1, that's equal to 1. So next we have 10, and this is the third term. So applying the same procedure, we have x. So since 4 is the first exponent in this term, the x is raised to 3. We will just subtract 1. Then in our y, since the exponent here is 1 plus 1, so that's equals to 2. Then just apply the same procedure until we go on the last term. So next we have 10. So that is 10 times x squared times y cubed, followed by 5 times x raised to 1 times y raised to 4. Then our last term, we have plus 1 times x raised to 0 times y raised to 5. Since the exponent here is 4 plus 1, that's equals to 5. Okay, then let's simplify this. So 1 times x raised to 5 times y raised to 0, this is equals to x raised to 5. Plus 5 times x raised to 4 times y raised to 1. So that is 5x raised to 4 times y plus 10 times x raised to 3 times y raised to 2. We have 10x raised to 3 and y squared, followed by 10. We will multiply it, so that is 10x squared times y cubed. Next, we have 5. 5xy raised to 4. Then our last term, we have 1 times x raised to 0. By the way, any number raised to 0 is equals to 1, so we can just cancel this one. Okay, then we have y raised to 5. Therefore, the expanded form of our x plus y raised to 5 is equal to this polynomial.
Last lesson, you have learned about the concept of combination and the Pascal's triangle. But today's video lesson, you will learn on how to find the nth term in binomial expansion using binomial theorem. For any positive integer n, the quantity of x plus y raised to n is equals to the summation of the number of combination n taken k times x raised to n minus k times y raised to k. So this formula is the concept of combination. So that is equal to n factorial over k factorial times n minus k factorial. Last lesson, we already used this formula, right? And today we will going to use this again in finding the nth term. Okay, let's proceed. Let's try this example. Let's try to answer x plus y raised to 10, fifth term. Let's identify first our given. N is equals to our exponent, which is 10. Then our k is, since our k represent 0 represent our first term, 1 our second term, 2 third term, 3 fourth term, and 4 is our fifth term. So meaning our k here is equal to 4. So using the formula, we can now find the fifth term where n is equal to k and k, where n is equals to 10 and k is equals to 4. So that is the number of combination of 10 taken 4 times x raised to n minus k, so 10 minus 4 times y raised to k, which is our 4, which is 4. So now we will get the value of our combination. So by applying the formula, that is equal to n factorial divided by k factorial times the quantity of n minus k factorial. So our n factorial here is n. 10 factorial divided by k factorial, so our k here is 4. So 4 factorial times the quantity of n minus k factorial, which is 10 minus 4. 10 minus 4 factorial. Okay, we will just simplify it now. 10 factorial divided by 4 factorial. 10 minus 4 factorial, that is 6 factorial. If you have scientific calculator, you can get the answer easily, but if you don't, we can simplify this expression until we get the final answer. 10 factorial is the same with 10 times 9 times 8 times 7 times 6 until we multiply it by 1. So times 6 times 5, 4, 3, 2, and 1 over 4 factorial, so 4 times 3 times 2 times 1, then 6 factorial, so times 6 times 5 times 4 until we multiply it again by 1. So times 4 times 3 times 2 times 1. So it's the same. So as you can see, this is the same, so we can just cancel this out. Cancel. Okay. 10 times 9 times 8 times 7, that is equal to 5,040 over, or divided by 4 times 3 times 2 times 1, that is 24. So if we divide 5,040 to 24, that is equal to 210. So it means the number of combination of 10 taken 4 is 210. Then we have x raised to 10 minus 4. 10 minus 4, that is 6 times y raised to 4. So this is the fifth term of our binomial.